Today we'll be talking about developing your inner Spidey Sense anomaly detection for applications, for your apps. I would specifically talk about Internet of Things application, but a lot of it also relates to other applications that you might want to introduce or integrate. Spidey Sense. Now, like I said, I got my shirt about Spidey Sense. It's a tingling sensation in the back of Peter Parker's skulls. If you're not familiar with Spider-Man, most likely you've heard of the Spidey Sense and all these remakes and a lot of remakes of Spider-Man movies. And it's that ability to sense and react to that danger before it happens. It helps Spider-Man detect evil and understand, even evil clones, right? In one of the movies, yeah. And it helped him navigate when he is impaired, when he's unable to see or hear what's going on around him. His spider senses identifies what's going on around him. It help him discover secret passages. And also, I think he used it to change his costume, right? If you think about it, it's like he knows when someone's watching or not. And it's using Spidey senses to change his costume or to change his mask and all that. It helps him fire the web shooters too, to identify where it's going to go and swing instinctively. He just knows. In real world, right? Real spider sense. It's called hyper awareness. It's called trichobothria. I don't know if I say that right, but it's that small little hairs that it's on the real spider that can detect low-level detections through their web, identify even vibrations within faint sound, and also identify small insects 3 meters away. So they know when to fight or flight, right? That's at the end of the day, and it helps them catch prey. And of course, we have web developers around here, new web developers. Of course, I had to show that because I thought it makes life interesting, right? Trying to learn how to. So that Spidey sense for us is that gut feeling, that that vibe that you kind of feel, especially if you've been doing web development, if you're doing a lot of software development for a long time, you gain that intuition. You kind of identify, hey, this code, I don't think it's gonna work. It's kind of harder to explain right now, but you have that feeling, you have that intuition because of what you've learned in the past. The scars, the battle scars. It also helps us discover the blind spots of things because of these Spidey sense that we have. So in programming, the way I see it, there's the higher level programming language, C#, a lot of the .NET, JavaScript, TypeScript, and all these different languages, Java and Python. Those are high level programming, and it goes through a compiler, and then from that compiler gets to a lower level programming language, and you have the assembly, WebAssembly with all that to be able to execute the machine code, right? So the same way as humans, we have our instincts and intuition, which what we call Spidey sense, which kind of like being able to detect when even though you're not looking, you have that feeling of someone's in the room or someone's watching you, those kind of things, or reflex. So that's kind of like our Spidey sense. You think about also in terms of a pro athlete, like in baseball, right? They don't, the person that is in pro athletes, like in basketball, they don't have to think where they where to block, where to shoot. They know there are 3-pointers and 2-pointers. They because of practice, because of the shot, they don't have to think about the angle and all that. They just know where to angle themselves, where to place themselves in the court. And then on the insights itself, it's more for us being able to identify and learn from our mistakes in the past. It's more, being able to have ideas, have those, when a pro athlete watches the video of his takes or watches other competitors, kind of identify what strategies we can do to improve the the game, right? So today we're going to be talking about anomaly detection and what is an anomaly detection. I'm going to focus on the time series anomaly detection, and we're going to do a demos and some takeaways. So anomaly detection is identifying unexpected items or events in the data set, which is so weird or so different. Like in the world we live in right now, it's totally different. My kids are at home, my wife and I are at home. That's not the total norm, but it's becoming the new norm, right? So it is an anomaly at first, and then it's becoming the new norm for us. It is an outlier, where the assumptions are for anomalies is that they occur very rarely in data. For the past 30, 20 years, kids go to school. Now kids have to be in the front of the computer, would do their video chat and do their class that way. And their features are different from the normal instance significantly. It's totally different. So causes of outliers, it could be artificial or non-natural or natural causes. Let me give you more examples of what I mean by that. Outliers can be from data entry errors. Data entry errors, you fat finger a number, but instead of 100,000 becomes 1 million. Those kind of things, and one extra zero, right? Another one is measurement errors, which is very common, and a lot of mistake happens because we're human, right? Or the machine fails to measure properly. Another one is experimental errors. It could be that you collected the data late in the sprint cycle or in the whole cycle of things, right? Of the data collection, and so it can be skewed because of that. Intentional outlier. A good example of this is, people under 18 or under 17 underreporting how much alcohol they drink, right? That could be intentional outlier when you're doing your surveys. Another one is data processing errors and how you extract it. Sometimes, you have your database and you're trying to extract data from it, and you do your conversion incorrectly or mapping incorrectly. You have a data processing error. Another one is sampling errors. A good example of that is, you're trying to get the height for all athletes, and you included few basketball players, and that would skew the whole uh, height, because that makes a difference. And then the natural outlier, that's when it's not an artificial type of error. So at the end of the day, what we're trying to do is we have our input data stream. We're looking at some data, and some of the data is defective, and we're trying to decide, is it anomalous or not, right? And depending on the algorithm we're using, we would say we can detect it. Most of the time it's no, right? Because anomalous only happens once in a while. But sometimes you won't be able to catch it because maybe it's not programmed, or we missed it, or most of the time we would catch it, but some of them we would think it's anomalous, but it's not. Like in this case, for this slot right here, right? And these are effective, and this one is not effective. That kind of thing. So that's when you go into the confusion matrix. I'm not going to focus on this, but it's more of identifying the accuracy, recall, and precision. How good is your model, right? How good is your algorithm to identify that it was able to detect, and how accurate it is to be able to detect your anomaly. At the end of the day, anomaly detection is finding a needle in a haystack. And I can see the needle, it's right there. But you get the idea. So some methods and how we would do anomaly detection, some of them could be rule-based, or we would use statistical techniques, or some machine learning. Folks, if you have questions, feel free to post it in the chat. I am monitoring them and I can answer them for you. So rule-based system. Rule-based systems, when we specifically identify the rules, if then else or switch statements, and typically we would use it to assign thresholds or limits. If the sensor data is more than a certain amount, then we flag that it is anomalous. If it's below a certain amount, we would flag it as anomalous. At the end of the day, we need the experience of industry experts to detect what is known, what is good and what is not, right? What is an edge case and what is not an edge case. Right? The problem with the rule-based system is it does not adapt to patterns, right? As patterns change, sometimes it would, the series have changed or the data set have changed. It does not automatically know until someone notices it, and then we can change the rules and assign new threshold. One problem with the rule-based system is labeling the data. Is it anomalous or non-anomalous, and identifying each one in order to train to have a good system. So this is a good quote that I believe in. Experience is the teacher of all things. That's why after a while, you have your industry experts, because they kind of have an idea. I used to work for an elevator company, and a lot of that industry, it takes time to understand how to identify anomalies. At the end of the day, an elevator is a car, right? Or has a motor, something that moves, but it takes some tweaking and identifying what are the correct values and correct parameters for the certain type of building, and each building is different from another one. So let's move on to statistical techniques. Statistical techniques is more when you use common statistical properties like mean, median, quantiles to identify and flag a data point. A rolling average or a moving average typically is what we would use. And most likely, if you're doing some stock trading, it would show you a moving average and rolling average, and you would know the stock of Microsoft spiked up or go down, and then you receive those alerts, right? End period simple moving average. One good example of that is Kalman filters for our sensor data. It's like a filter to kind of clean the sensor data because it's too noisy, right? To kind of smooth it out so that you don't get a lot of noise. It could also be histogram-based outlier detection that you might be interested in or might be included in. So the good thing about statistical technique is it's more interpretable and more useful than ML methods. So it might make sense to just get the median or mean before you even move to machine learning. So it depends on the use case. So just to kind of give you an idea, when do we use anomaly detection or when do we use supervised learning? So this is for machine learning type. So for anomaly detection, if you only have a small number of positive examples, small number of anomalies, then you would use anomaly detection techniques. If you have large number of positive and negative or something that would be equal, then it makes sense to use supervised learning for that. Another one is through, if you have large number of negative examples, anomaly detection might be better to use. And if you supervised learning compared to supervised learning, if you have enough positive examples for your algorithm to learn, then it makes sense to use something that has supervised learning. Many different types of anomalies. Sometimes it's harder to find positive examples because you hasn't discovered yet. Even your industry experts may have not thought of it yet or have not encountered it yet. So that's when you use some anomaly detection techniques, and it may have not been discovered. But if it's on supervised learning, a good example of that, I'll show in the next page to kind of understand when to use anomaly detection versus supervised learning. Anomaly detection is more for fraud detection. That's why we're using it. I bet you've already experienced it, where your credit card suddenly gives you an alert because someone else used it outside, or when you were traveling, it was not something that it was not usual. It's an anomaly, so sometimes it turns off or disables the credit card, or you would receive a notification. So which is a good thing. Manufacturing, you have an engine going through its cycles, and then suddenly one of the sensors was broken or the motors are broken, and then that would be a good manufacturing use for anomaly detection. Data centers, and we're going to talk about Internet of Things here next. Supervised learning is more email spam classification, right? Spam or not spam. That would be a good use for supervised learning because there's a lot of examples out there. Just a matter of collecting the right data. Weather prediction, because it's always either sunny or cold or rainy. There's a specific set that it can only happen. Of course, there's strange weather phenomena, but we're not going to talk about that today. Cancer classification, you already have experts that can identify different types, right, of cancer. So that might be a good use for supervised learning. So machine learning methods, there's supervised, unsupervised, and self-supervised that you might want to look into. Supervised learning would be something more decision tree, long-term, short-term, and forecasting, and of course vector machines. Unsupervised learning, that make more sense for the K-cluster means or DBS can. Self-supervised is a combination. That's when you do LSTM autoencoders, if we're talking about machine learning models. I'm not going to focus so much on these. I want to focus what I wanted to tell you guys. There's different algorithms that if you want to implement this yourself, you can. There's different algorithms that is available out there to research. It could be density-based anomaly detection, where most of your good cases or normal case is in one spot, and then anything outside of that spot is an anomalous, considered anomalous. So that could be density-based. It could be cluster-based. You split it into clusters. That's when you use k-means algorithms type of. Another one is using Gaussian distribution. How you calculate the Gaussian distribution for any data point, and if it's outside of the normal, and it would be considered anomalous. So that's one way to look at that. One class SVM, the support vector machine, you can use that too, and PCA-based anomaly detection. So let's talk about Internet of Things, how you would use to the Internet of Things world is possible because there's an increase of data volumes. Sensors right now is really cheap, and because of that increase of speed and improved networking, that we were able to collect more data from our machines and send them remotely. And because of that too, one thing that you had to consider every time you would do deployment of Internet of Things data is, or Internet of Things project, is the risk environment. even though the data is moving very fast, failures are not tolerated. Meaning, it could be something that is, something that people depend on more compared to other types. You have to consider that the failures too. So sometimes Internet of Things becomes an Internet of broken things, meaning it's not easy to find bugs when you have streaming data coming at you and identifying faults or identifying anomalous data. So that's when you use the artificial intelligence of things, and you'll hear that more and more. And like I said, I talk about where you have your insights, the interpreter module, and your instincts and intuition. In 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 AIoT, you have your edge gateway or real-time devices that's collecting data and send them up to the cloud, and you have your device twins um, receiving data or matching that data as a virtual representation of your sensors. And then, of course, you have your business intelligence, your dashboard, to be able to detect and to get some insights, right? That's where we map that into our systems. So in time series, there are different types of anomalies that you would encounter. One of them could be outliers, spike and level shift, pattern change, and seasonality. So outlier would look something like this. You have your sensor data, and then suddenly there was a spike, right? See that spike up there. So that's typically an outlier. Another one would be a spike and level shift, right? So there's the motor or the usual data collection that you have, and suddenly it changed the that there was a spike, and then there's a level shift. Another one is a pattern change, right? So you have, typically your data collection is this, and then suddenly there is an obstruction, and there's less data that you're receiving, or min and max have changed. So that's a good pattern change. And of course, seasonality. Uh, ice cream sales are higher during summer versus winter, right? You know, forests are busy around, you know, around Valentine's Day and around Mother's Day, right? And of course, pizza sales are up uh, during Super Bowl, right? And that's when you have the seasonality that you have to consider when you're receiving your streaming data. So production issues can be harder to to stop, like a moving train. So whenever you're talking about Internet of Things and getting some data, receiving data sets, uh, and using anomaly detection for it, you also have to think about your data sets. Is it identically distributed? So, which means that the distribution does not fluctuate, and all items in the sample are taken in the same probability distribution. One good example or analogy of that is, using your roulette, right? It every time you has a turn, the ball, you spin it, and it's identically distributed and independent from each other from the previous game, right? And they're all independent from each other. So time series anomaly detection algorithm that's out there, typically you would identify the spikes and the change points. Spikes with temporary burst of behavior in the system. Change points would be related to persistent changes over time or level changes in trends. So in terms of Internet of Things, we talk about the business intelligence, the cloud devices, and the edge devices. In anomaly detection in IoT can be either in, you can have it in the ML.NET. Like in my demo today, I'm going to talk about ML.NET in edge devices, Also, you can have anomaly detection in Azure Stream Analytics. That's on when you're receiving data from the cloud and you would want to some alerts and anomaly detection in your streaming data. And then Azure Cognitive Services, you can also incorporate it to your dashboard and your business intelligence. One thing to visualize what intelligent kiosk, what anomaly detection is, as just want to show you guys, is this intelligent kiosk samples right here. This is available on GitHub, and one of the examples there is Anomaly Detector. So just to visualize this manufacturing, we have this machine that we can detect anomalies right there. So there's that pattern, and you see there's that time span. That's where it's identifying anomalies and learning from this historical data. And when there's out of that pattern, it would identify, and based from what we specify here on our sensitivity, would identify, hey, that's anomalous, and this is out of its range. It's unusual. So that's one way for us to kind of identify what are the needs whenever you use these anomaly detection algorithms that is out there. And I'm going to focus today on time series data and this, talking about time series data. So let's start about ML.NET. ML.NET is an open source cross-platform machine learning framework for .NET. At the end of the day, you can deploy ML.NET on on-premises device, deploy in Azure, any cloud, and you can even deploy it into just about everything. It's at the end of the day, it's focus on developers, right? For .NET developers, built for .NET developers that already have C# skills, F# skills, that want to integrate machine learning into their .NET application that has not have a lot of data experience or data science experience or machine learning experience, and it's not required for us to have that. So in ML.NET, there's a time series catalog that we can use that is already part of that. These are some of the algorithm studies available out there. One that we can start using. Today, I'm going to use the detect IID spike, which is that would detect the changes in the algorithm, but predicts spikes instead of change points. So we're going to do a demo on that here. So in ML.NET, this is my ML.NET project. So this is my .NET Core applications console app, and one of the requirements in order to use ML.NET is to include NuGet packages Microsoft.ml, and in order to get the time series catalog, we include the Microsoft.ml.time series. To do that. So my data looks like this. I have a CSV data that I'm going to load to my program, that I have these temperature, humidity, right? Temperature, humidity, and the time that I receive the data, and which device, like in this case. So my program right here, I have two classes. I have my initial temperature and humidity data that is mapped to my the columns on my CSV data. Like in this case, I need column 2, column 3, which is my temperature. But notice that my temperature is a string, right? This one right here, they're string and value. And what I want to do is I need to convert it to something that is float so that I can use it for my algorithm. So I need something that would create a new table that inherit from that initial temp humidity data, and I have float there. And then we need our prediction, right, to identify if it's anomalous or not. So In order to use ml.net, we have our using statements right here, using Microsoft.ml and Microsoft.ml.data is what I'm using. Okay, and go back to the main program. So what I'm doing here is I'm loading the CSV file. In order to use ml.net, you need the ML context. So new ML context, and then everything that you need is in that ML context. So ML context.data, that means I'm trying to load some from my text file using this pattern, initial temp humidity data. It's a comma separated value, and it would load it to this data view. Data view is what this load text file would return, that I can use it for my pipeline. So in this case, I created a pipeline. So in order to create pipelines, you do ML context that transforms, and I'm doing conversion. I wanted to convert the temperature column in my CSV text file, the input temperature, to have it in this temperature column. Like in this case, my input humidity, which is a string, and I wanted to convert it to float. And in order to do that, I would do pipeline.fit and create a transformer, and transform would give me the converted data set. Moving along to this detect, I detect spike right here, where this is where I would use the ML context again, and with transforms, this detect IID spike is the time series from the time series catalog, and I have to identify which one with 4 parameters that I need to pass in. First thing is the input column name. In this case, I would like to get the temperature data, right? Not the string one, but the converted float column from my iData view. And then my output would be adding this prediction column. That's as my output column name. And here I have to pass in the confidence. The lower this value is, the more anomaly detection it can detect. The higher that value is, it has to be at least 95% confident that it's anomalous before it would detect it. And this p-value history length, if you're looking at this, that's how far it looks back from your data set, right? So right here, this is my latest data set, because it's a time series data. It looks back, in this case, it would look back the last 25 items on my history. And then on here, since there's no need for training, I would, in order to do, it's always that pattern of fit and then transform every time you would use MLNet or this ML context, right? So you always have to pass in a fit from your estimator. In this case, I would create an empty data view, because it doesn't need training. It trains as it goes, as it receives the data. And then from that transforms, I would transform that temperature humidity data view, and then that would give me the prediction. In this case, I'm using it as a batch process. So let's try to run it. When I already ran this, let me run it again right here. So now, right now, it's compiling it. It goes through, and this is going to be my output. So as I receive the data, or as this is my CSV file with all the rest of them, it looks at the last, we specified last 25 items, right? Going back to the code, the last 25 items. So in this case, if you're looking at this spike has been detected here. This is based from the data that it had, 25 items back. And so in this case, it jumped up to 124. So that's why a spike was detected. And you notice how there's that precision value, or that value that identifies the confidence level. In this case, it's 98% confident that there was a spike that was being detected. So since we specified 95%, this one won't get detected because that's 94%, 94%, right? This one is 92%. Anomalous. Okay, so that's what we have for our ML.NET demo. I'm going to move on to, of course, the ML.NET 1.5.1. Actually, they just released it a few weeks ago. The ML.NET team, there's new things that you can do with it now. It talks about seasonality, root cause analysis. If you're interested in learning more about that, there is a blog post out there. Now we'll move on to the streaming analytics, or Azure Stream Analytics, where you have your data, right? You have your IoT device, and you're sending that sensor data to, IoT Hub or through Event Hub, and then you would receive it and map it to your IoT or to your Azure Stream Analytics, and you have a way to process the data as you receive it, and then deliver it to your dashboard, Power BI, or you can create actions or alerts, through sending it back to Event Hub or Azure Functions. So at the end of the day, this is the algorithm how you would call anomaly detection in your in Azure Stream Analytics. So as you receive the data, you would pass in this anomaly detection spike dip. You would call this one. You pass in this case, I'm using the temperature, and the same kind of have the same parameters. Like in this case, I have 95% as my in terms of the accuracy, and then this one looks at 120 items back. In this case, you split up your data as you receive it into the last 120 seconds. So it would only receive the last 120 seconds and pass it to this algorithm, and that's where it's going to use to detect from that latest input, is it anomalous or not. And then based from this anomaly detection step, it would get passed into here to where we can identify the score, and then is it anomalous or not. Kind of the same way as for change point, about the same algorithm, but instead of using the spike, we would use anomaly detection underscore change point to do that. So going back here, what we're going to do today is I already set up, using IoT Hub, I have these simulator that would send data every minute to IoT Hub. And then based from that IoT Hub, I have streaming analytics connected to that inside Visual Studio Code, and would listen to that temperature data. And if there's anomaly, then send it to a blob storage. So that's what we're going to do today. So this one right here, that same program, I found out there's an extension in the marketplace how you would use, or you can incorporate not anomaly detection, but Azure Stream Analytics. There's Azure Stream Analytics here. Azure Stream Analytics. Yeah. Tools that you can use in order to have it inside Visual Studio. So that's what I'm going to do right now. And what I'm going to do is I'm going to run this program locally with the live input. But before I do that, let's go back to the Raspberry Pi simulator. This Raspberry Pi simulator, what it does is I have the connection string and connected to IT Hub. And if I run this, every minute, it would send message to my IoT Hub with the current temperature from this simulator. Is just a randomizer. Sends it up to my IoT Hub, and then I have my IoT Hub connected to Azure Stream Analytics. And I'm going to run this same algorithm. I'm going to receive the data locally through here. And as I receive it, you'll see what I'm talking about here. As I receive it, it would identify, is it a spike in that percentage? Of course, there's no, it hasn't received a lot of data yet. So it always would identify, hey, it's anomalous, 0 and 1, that means 1 is anomalous, 0 means it's normal. And of course, this program right here is randomizing just values and sending it up. But what I'm saying is that this program would send data, and as I receive it, I would process if it's anomalous or not. And if it's anomalous, then I can send the alert that way. Cool? Okay, I have a few minutes left. Let's move on to Azure Cognitive Services. Azure Cognitive Services has different APIs out there that you can use, and of course they have APIs for web search, vision, speech, language. Today we're going to focus on one part of the Azure Cognitive Services, which is the decision. And there's this in preview right now, is an anomaly detection, the Anomaly Detector APIs. So Anomaly Detector API, it's a way for us to identify, but it's the same as what we're looking at. In this case, it's a RESTful API. You can monitor abnormalities that way. You can fine-tune its sensitivity, and it's currently used by 200 Microsoft product teams. Anomaly Detector, you can use it for real time. You can also do batching. So you can use it for your Power BI dashboard, or you can use it as part of your application, or as you receive the data from your sensors. You can get additional information about your data that way. And also another way, you can adjust the anomaly detection boundaries too. So how it's working on the back end, as it receives the data, it automatically identifies which anomaly detection algorithm would work well with the data set that you passed in. And these are different algorithms that it's currently using right now, that it is available, that it automatically identifies, hey, would this work well with SRCNN or just a Fourier transform and all that. Let's look at the demo. I have my Raspberry Pi here, and it has a Sense hat on it. And if you're interested in learning more about how I was able to connect this Raspberry Pi to this Jupyter notebook, because this Jupyter notebook is actually running in my Raspberry Pi right now. So I'm running .NET in Raspberry Pi on using .NET Interactive, be able to get information about my sensor and use it to send that data to and call the cognitive services anomaly detector to identify anomalies. So in this case, I already, this is how you would incorporate or add anomaly detection, or this how you would add NuGet packages in your Jupyter notebook. And in this case, this is how I would be able to connect to the Sense hat. The Sense hat is, you're looking at this, these are the LED that is on top of my Raspberry Pi 3. It's running right there. So what I'm trying to do here is I want to read the temperature on my Raspberry Pi, on my Sense hat, and use asynchronous streams. So as I receive the data, like in here, every minute, it would read the temperature and send it back for this code. And once this code would receive it, I would round up the time because I don't know what time I would receive it. But my goal is to be able to, so like in this one right here, I'm using asynchronous stream, right? Read my temperature data, and every time I would receive it, I would add it to this table or this list right here that has 2 columns. This is a, I need date, time, and value tuple, right? So as I receive it, it would look something like this, right? It rounds up the time. So in that way, it's kind of clean as I receive the data. The reason why I say that is because the Anomaly Detector API requires me to have this kind of format, something that is rounded up, I would say, or something cleaner, so you can identify the correct data set. There is a NuGet package out there that that you would use in order to use the cognitive services anomaly detector in C#. So it's NuGet Microsoft.Azure.cognitive services.anomaly detector. And then on here, what I'm doing here is I would, the parameters that I would set. So I would pass in the list of, to get the series of data, and convert it to this request, a request model, or so I would pass that in, but I have to specify, hey, the data that I'm sending in has the granularity of per minute, and 1 per 1 minute, right? So it gives a hint when it calls the API, it is a per minute value. So how you would run it using Anomaly Detector, you do that. So in this case, I have this, what we want to do is call the API, right? So we have this Anomaly Detector client, and there's last detect async that you pass in your request, and that would give you the result if it's anomalous or not, based on the parameters that we set in here. So in this case, what I'm doing here, once you set up your anomaly detector in Azure, right? So let me point you to that. Let's see if I can. So it would give you, in cognitive services, it will give you a key and value pair, and you have to pass in, kind of like any API call, you have to know your endpoint where you're connecting it to Azure API. In this case, in Azure, when you create a cognitive services instance, it will give you an endpoint and a key, how you would connect to that. Okay, so let's try to run this. This would read my config.json with my endpoint and subscription key. Once I have my subscription key, I would connect to that API with my subscription key and endpoint. And then based from that, what I'm going to do is I'm going to look at the last temperature, and I would assign it to something like a big number, and I would call that temperature. I would create a request, and based from that request, I would call this last detect sample async that we have over here. That would call the API properly. And then if it's anomalous, right, I would make this to red. So let's try that. Hopefully I'll be able to demo that properly. Okay, right here. So watch it. Okay. So if it's anomalous, it would turn red. There you go. It did turn red because our last number from our data set is 200. Run this multiple times. And then to turn it off, I can just call it to black. So that's one way of alerting. Okay, let's go back to the presentation. So where can you use Anomaly Detector APIs? Oh, sorry. You can use it here C#. There's also, it's an API, you can use it through JavaScript or Python. You can use Docker containers, incorporate it to your Docker containers. You can actually use it for Power BI and incorporate it with Azure Databricks for streaming data. So then the best superpower you can give to any IoT project is a Spidey Sense. If you're interested in learning more about or getting the link to my presentation and my demos, there's that link to the GitHub page to learn more about this. If you're interested in learning more about me, the best way to contact me is through LinkedIn with my LinkedIn account out there. I am a lead and software engineer at Spacey. I am a Microsoft MVP. I would really appreciate if you can give me feedback to help improve my presentation skills. Thank you very much. I applaud you for taking your time learning more about anomaly detection. Thank you. Any questions out there? Feel free to add it in the chat if you have any questions, or if you have if you need the link to the presentation, let me go back to that previous one. And hopefully you gain some insights in the world of Spidey senses and anomaly detection. Thank you. Cool. So tomorrow I'm going to have another presentation, and tomorrow is about the Jupyter notebooks and how it's about the same way how we would use Jupyter notebooks with .NET, and I would be demoing the one how I did it on Raspberry Pi, and how you would go through use .NET and C# in Jupyter notebooks running inside a Raspberry Pi. And it's about the same time, of course, different channel, right? But around the same time, 10 o'clock my time, 11 o'clock is on that schedule. Thank you. Cool. I'm going to be hanging out here for a few minutes until 11 o'clock. So if anyone have questions or anyone have feel free to ask in the chat. Thank you very much. Thank you for a great session. Thank you, Veronica, Stephen, and Rebecca. That's good. Good to know that this session is helpful.